All right, so first, in terms of building up a confidence interval for a mean, we check the conditions, which is independence and normality. We use a sample mean, x bar is the point estimate. This represents your best guess from your sample to estimate the true population mean. We calculate the standard error using s over the square root of n, where s is the standard deviation and n is the sample size. So standard deviation divided by the square root of the sample size to calculate the standard error. From there, we'll find the confidence coefficient, t star, using a t-distribution table. And then x bar plus or minus t star times standard error, so point estimate plus or minus confidence coefficient times standard error. We'll calculate the confidence interval. This represents the range of plausible values for the true mean. Now, again, the conditions. To proceed with the t-distribution for inference about a single mean, we need to check two conditions: independence of observations, and the observations come from a nearly normal distribution. And we verified the independence condition just as we did before by collecting a simple random sample from less than 10% of the population, or randomly assign subjects into treatment and control groups. The normality condition can be difficult for small data sets. Often the best we can do is look at a plot for obvious outliers or departures from the normal model. Or we can at least verify that the minimum and maximum values are not beyond 3 standard deviations from the mean. That is, the z-scores are between -3 and +3. When examining a sample mean and estimated standard error from a sample of n independent and nearly normal observations, we'll use a t-distribution with n-1 degrees of freedom. That is, the degrees of freedom is the sample size minus 1. For example, if the sample size was 19, then we would use a t-distribution with 18 degrees of freedom.